So what's up guys, welcome to our first video lecture series. So today I'm gonna show you how to unbox the STL-27 LiDAR from LG Robot. So this is a cheap LiDAR sensor that I purchased for around $100 US. Pretty cheap, right? Let's dive into it. So this is just the connector cables right there, and then this is the STL-27 LiDAR, which with a range of 0.03 meters to 25 meters. Yeah, which is pretty good for a low cost LiDAR. Then this one is the CP2102 module, the USB to UART module. So now I'm gonna dive into the connections on the LiDAR sensor. So from the far left we have the TX, and then from this followed by the pulse width modulation, followed by the ground, and then the VCC, which is a 5-volt input. Then now on the CP2102 module, the connections, the UART connections are written. We have the 5-volt VCC, we have the ground, the RX, and the TX. So now I'm gonna dive in to show you how to connect the CP2102 module to the LiDAR sensor. So this is pretty simple. We just connect the connector cable to the LiDAR sensor like this, and then now it's just a matter of matching the connections. So the red cable from the right is the 5-volt cable connected to 5-volt, then followed by the ground, which is the green cable connected to ground. Then now the TX from the LiDAR sensor is connected to the RX in the CP2102 module, which is connected to RX. So this is pretty easy, right? So the next step is to dive in and connect this the USB to UART module to the laptop and see if our connections are accurate. Let's dive into it. So connecting to the USB port, and boom, our LiDAR sensor is on, and we are ready to dive onto configuring it to the ROS. So what's up guys, welcome back to our YouTube channel. So this is the second video of our video lecture series. So basically this means I didn't quit during the first video. Interesting, right? So in this video I'm basically gonna be focusing on configuring the STL-27 LiDAR with ROS 2, and my distro is Jazzy. So the most interesting output of this video will be visualizing the scan data in RViz 2, and also reading some ROS 2 LiDAR messages. So let's dive onto it. What are we waiting for? So the first thing I'm gonna do is open the terminal, then create our workspace where we are gonna do all our stuff, which is I'm gonna call it the STL-27 LiDAR workspace. Then I'm gonna create the source directory. Awesome. Then I'm gonna dive into the workspace, into the source. Then the next thing is to clone the resources that we were given by the LD with the LD Robot sensor team. So don't worry about all these commands, as I'm gonna give you in the description below. So let's clone using git clone. Okay, github.com. Okay, so this will depend on the strength of your internet connectivity. So let's get onto it. So I'm cloning into the LD LiDAR STL-ROS2 and done, which means my internet connectivity is a bit fast. So let's move on to the second step. So the next step now is to check the USB port of our STL-27 LiDAR, which is I'm gonna use ls dev ttyUSB, and I'm gonna check for the port. Awesome, which is our LiDAR is being recognized on dev ttyUSB 0. So I'm gonna dive into sorry about that. Okay, I'm gonna dive into this workspace and then the launch, which is in this workspace, in this directory. So I'm gonna dive into the launch and then I'm gonna edit the STL-27 launch file and tell it the USB port on which our LiDAR sensor is connected. So I'm gonna use gedit STL. Okay, so let's check for the USB port, and in this case it's dev ttyUSB 0, which is correct for our functionality. So let's save, then go on to build our workspace. Let me clear this to make things a bit orderly. Yes. Okay, so now I'm gonna build the workspace using colcon build. Okay, so now we are building our workspace, and okay, interesting, we have an error now which says there is a file in LD LiDAR driver source logger which is called module.cpp, a C++ file. And what does the error say? The error says pthread mutex unlock was not declared in this scope. So this is simple. I'm gonna show you how to debug this error, and it's pretty simple. So let's dive onto it. So some might prefer using the terminal, and some might prefer diving into the C++ file manually, which is what I'm gonna do. Okay, so let's dive onto the file. Okay, source, okay, then driver source logger. Okay, this is the file. So we are just gonna debug this error by including the header, which is the pthread header, which is missing in this file. So #include, this is simple C++ syntax, pthread .h. Awesome. So let's save this file and then go on to build our workspace. Colcon build again. Interesting. So we've successfully debugged this error, and we've successfully built our workspace. So now the next thing is to source our workspace, and then source the bash rc Awesome. So now we are good to go. We can now launch the launch file for our STL-27 LiDAR. Okay, so let's use ROS to launch. Okay, LT LiDAR. ROS2. So this is our package name, and then the file. Okay, so now let's launch it. Awesome. So now let's split our terminal horizontally, and let's do ROS topic list to check, ROS2 topic list to check if the scan topic is now available. ROS2 topic list. Okay, now we have the scan topic which is now present. So let's do something. Maybe let's echo the topic once and see how the ROS2 LiDAR message looks like. Okay, ROS2 topic echo. Let's echo scan once. Interesting. So this is our scan message, whereby we have the header, the timestamp, the frame ID, which is the base laser, the angle mean, the angle max, which is 360 degrees in radians, sorry, from radians to degrees, which is 360 degrees, the angle increment, time increment, the scan time, the range mean, which is 0.01 meters up to 25 meters. Pretty interesting for a cheap $100 LiDAR like this one. Okay, so these are the basic LiDAR scans that we are getting. 0.2 meters. These are the rays, 0.2 meters. Okay, so these are objects that are nearby the LiDAR sensor. So now I'm gonna open RViz 2 so we can visualize. Okay, so basically you can see we have successfully visualized our LiDAR scans in RViz, and we have configured the STL-27 LiDAR with ROS2. So don't forget to like, don't forget to subscribe to this channel, as I'm gonna upload a lot of tutorial series up to converting the 2D LiDAR scans to a meaningful 3D point cloud, which is, we have a lot more series which are upcoming and are gonna be uploaded by my team. So stay tuned, guys. Thank you for watching. Cheers.